It's Brad, and today's video is on Beer's Law.
So today let's talk about Beer's Law. This is the idea that for colored ions in solution, the concentration of the ions determines the intensity of color in the solution. So the idea is that the concentration of the ions is somehow going to be proportional to this intensity of color. So let's remember what we know about color wheels. See if you can remember the idea about complementary colors. See, red and green or blue and yellow, these are what we call complementary colors. So we're going to use these complementary colors to analyze a solution. Here's the setup. We'll have a solution, this one's blue in color, and we'll shine orange light through it. The complementary color of blue is orange. So the light source here will emit the light, it'll pass the solution and be attenuated somewhat by absorbance in the solution. We'll have a detector that detects the light incoming with an intensity I somewhat less than 1, and the light source will send it with an intensity of 1. The absorbance will just be I minus 1. So in mathematical terms, we're going to use this sense of absorbance, and that is the idea here that the absorbance will be equal to some simple expression, A, B, C, where A is an experimentally determined constant, B will be the path length through the solution, this one right up here, just get that length through there, and C will be the concentration of the colored ions. So the absorbance will be greater if the concentration is greater or the path length. And notice that this A and B factor will be fixed for an experiment, and we get the idea that the absorbance will be proportional to the concentration only if we hold the other two values constant. So here's a setup. This is what's inside the actual unit we'll be using. We have a lid here, there's a light source, this is the cuvette with a sample inside, we have a light detector, there's the blue sample, the orange light shining through, and there's the actual unit we'll be using, which is a vernier colorimeter. In any case, what the analysis looks like, we'll make a graph, it'll be absorbance versus concentration, and we'll get some solutions whose concentrations we know, graph them, make a straight line of best fit, and then use that for a solution whose concentration we don't know and whose absorbance we can measure, and just calculate backwards. So the idea is make a line of best fit on the known concentrations, and then after that, use that same line of best fit to determine the concentration of an unknown sample, of course, whose absorbance we'll measure. So that's the whole story with Beer's Law. Make sure you have a look at the next two the next two videos in this playlist, and stay tuned for our next lesson, determining a KEQ.
This is my dad's YouTube channel. It's awesome. So like, comment,